You've been told that AI is going to change everything, that it's super intelligent, that it understands language like humans do, that it's either going to save the world or destroy it. But here's what's actually happening. Almost none of that is true. And the people building these systems, they'll tell you the same thing, if you ask them the right questions. The gap between what AI actually is and what we're told it is might be the biggest disconnect in modern technology. And that disconnect is costing you in bad decisions, wasted money, and a fundamental misunderstanding of the most important technology of our time. Let's start with what artificial intelligence actually means, because the term itself is almost 70 years old. In 1955, a mathematician named John McCarthy coined the phrase for a summer workshop at Dartmouth College. His idea was simple. Maybe every aspect of learning and intelligence could be described precisely enough for a machine to simulate it. Notice what he didn't say. He didn't say machines would be intelligent. He said they could simulate intelligence. Why does this matter? Because when something is simulating intelligence rather than actually being intelligent, it behaves completely differently. It has different strengths, different weaknesses, and most importantly, different failure modes. Understanding this difference is the key to everything else we're going to talk about. Think of it like an incredibly sophisticated autocomplete system. Your phone's keyboard suggests the next word based on what you've typed. AI does the same thing, but it's been trained on so much text that its predictions are remarkably human-like. When you type "the weather today is," your phone might suggest nice or terrible. When you ask ChatGPT about the weather, it's doing fundamentally the same thing, predicting what words should come next, but with vastly more training data and computational power. You know when you're watching a movie and you completely forget the actors are just playing characters? The actors aren't actually the people they're portraying. They're just simulating those characters so convincingly that you suspend disbelief. AI works the same way. It's software that can perform tasks we normally associate with human intelligence, recognizing faces, understanding speech, writing text, making predictions. But it's not intelligent the way humans are intelligent. It's performing intelligence. Think about your smartphone's camera. When you point it at a friend and it draws a little box around their face, that's AI working. But the phone isn't seeing your friend the way you see them. It's running mathematical calculations on pixel patterns it's been trained to recognize as faces. It's incredibly good at this simulation, but there's no understanding happening, no consciousness, no, "Oh, hey, that's Sarah" moment. This absolutely matters because almost every conversation about AI gets completely derailed by this confusion. When someone says AI understands language, they usually mean AI can process and respond to language in ways that seem like understanding. The difference between those two things? Enormous. So what is AI really? It's a category of software technologies that can recognize patterns in data and use those patterns to make predictions or generate outputs. Some AI recognizes patterns in images, some recognizes patterns in speech, some recognizes patterns in text, and some, like the systems you've been hearing about, can do multiple things at once. Now let's talk about how these systems actually work, because this is where you can see behind the curtain. Let me show you what's actually happening inside these systems. I'm going to use modern language AI as our example, like ChatGPT, Claude, or Gemini, because they're what most people think of when they hear AI today. Imagine you're learning a new language by reading millions of books in that language. You don't have a dictionary, you don't have grammar rules, you just have examples. Lots and lots of examples. After reading enough, you start noticing patterns. You see that certain words tend to appear together. You notice that when someone writes, "the cat sat on the next word is probably mat or chair or something similar, but probably not 17 or purple. This is essentially what large language models do, but with one crucial difference. They're not learning meaning, they're learning statistical patterns. They're becoming incredibly sophisticated prediction engines. The process works like this. First, you take massive amounts of text, books, articles, websites, conversations, and break it all down into smaller pieces called tokens. Think of tokens like puzzle pieces of language. Sometimes a token is a whole word like cat. Sometimes it's just part of a word like un or ing, and sometimes it's punctuation. Each token gets assigned a unique number, kind of like how every book in a library has a unique call number. So the sentence, "The cat sat," might become the numbers 245, 1847, 392. Now all that text is converted into numbers the computer can work with. Then you feed all this numerical data into a neural network. Instead of thinking about this like a brain, imagine it more like a massive spreadsheet where each cell contains a number that represents how strongly different tokens should be connected. If the word cat often appears near sat, the number in that connection gets bigger. If cat rarely appears near quantum, that connection stays weak. During training, the system looks at partial sentences and tries to predict the next token. When it gets the prediction wrong, it adjusts those connection strengths slightly. When it gets it right, it reinforces the connections that led to the correct answer. This happens billions and billions of times across trillions of examples. Gradually, the network develops an internal representation of how language works, not the meaning of language, but the statistical patterns of how words and phrases fit together. The key insight? After enough training, something remarkable happens. The system doesn't just memorize specific sentences, it develops the ability to generate new text that follows the same patterns. It can complete sentences it's never seen before, answer questions it's never been asked, even write in styles it learned from the training data. But, and this is critical, it's still just predicting the next most likely token based on statistical patterns. When ChatGPT writes a poem about love, it's not feeling love or understanding love. It's generating text that statistically resembles how humans write about love. Here's where things get weird and complicated, because these systems can do things that seem to require real understanding, even though we know they're just doing pattern matching. For example, you can ask GPT-4 to solve a math problem it's never seen before, explain the steps, and it'll often get it right. How is that possible if it's just predicting text? Well, during training, it saw millions of examples of people solving math problems and explaining their reasoning. It learned the patterns of mathematical reasoning well enough to replicate them. It's not thinking through the problem, it's generating text that follows the pattern of how humans think through problems. This creates some truly confusing behavior. These systems can write code, translate languages, summarize complex documents, and even engage in what seems like creative problem solving. But they can also fail in ways that reveal their fundamental limitations. Ask an AI system how many R's are in the word strawberry, and it might confidently tell you there are 2 when there are actually 3. Why? Because it doesn't see letters the way you do. It sees statistical patterns in how words are typically processed and tokenized. It's not counting letters, it's predicting what answer would typically follow that question. Or try this. You can ask ChatGPT to write a story about a character who's afraid of the color blue, and it'll create a compelling narrative with psychological depth. But if you then ask it what color the character's shirt was in paragraph 3, it might confidently give you an answer that contradicts what it wrote just moments before. It's not keeping track of the story world it created. It's generating each response based on the immediate context. This reveals something important. These systems are simultaneously incredibly capable and fundamentally limited. They can perform many tasks that seem to require intelligence, but they lack what researchers call persistent state. They don't maintain a continuous understanding of the world or even of their own previous outputs. But wait, there's another wrinkle that's crucial to understand: the training process. These systems learn from human-created text, which means they absorb all of our biases, mistakes, and inconsistencies. If the training data contains more examples of men being described as doctors and women as nurses, the AI will reproduce those patterns. If the training data includes false information presented as fact, the AI might confidently repeat those falsehoods, and it gets even more complex. Modern AI systems go through additional training called reinforcement learning from human feedback. Essentially, humans rate the AI's outputs as good or bad, and the system learns to generate responses that humans prefer. This makes the AI more helpful and less likely to say harmful things, but it also makes it more likely to tell you what you want to hear rather than what's necessarily true. The result is systems that are incredibly convincing but not necessarily accurate, helpful but not necessarily honest, and creative but not necessarily original. They're like extremely talented improvisational actors who can play any role convincingly, but they're still just performing. So why does any of this matter to you? Because AI is already making decisions that affect your life, and understanding what it actually is versus what it appears to be is crucial for navigating the world we're living in. When you apply for a loan, AI systems are evaluating your creditworthiness. When you search for information online, AI determines what results you see. When you use dating apps, AI decides who shows up in your feed. These systems are making consequential decisions based on pattern recognition, not understanding. This has real implications. If you know that AI systems are pattern-matching machines, you can better understand their limitations. When an AI-powered hiring tool shows bias against certain names or backgrounds, it's not because the AI decided to be discriminatory, it's because it learned patterns from biased training data. When a medical AI misses a rare condition, it's not because it's incompetent, it's because rare conditions, by definition, don't appear frequently enough in training data to create strong patterns. Understanding this also helps you make better decisions about when to trust AI and when to be skeptical. AI systems are excellent at tasks where pattern recognition is the primary requirement: translating languages, generating first drafts of writing, analyzing large datasets, or suggesting products you might like. They're much less reliable at tasks that require real understanding, creative problem-solving, or dealing with novel situations. For your career, this matters enormously. The jobs most at risk from AI aren't necessarily the ones that require the least skill. They're the ones that involve the most predictable patterns. A radiologist looking at standard X-rays is doing pattern recognition. A lawyer writing standard contracts is following templates. A financial analyst creating routine reports is applying known formulas to new data. But jobs that involve true creativity, complex problem-solving, or deep human interaction are much harder for AI to replicate. Not because they require more intelligence, but because they require the kind of understanding and adaptability that current AI systems simply don't possess. There's also a personal dimension. As AI becomes more prevalent, you're going to encounter it constantly. In customer service, in search results, in social media feeds, in news articles. Knowing that you're interacting with sophisticated pattern-matching systems rather than intelligent entities changes how you should approach these interactions. When an AI customer service bot seems to understand your problem, remember that it's matching your words to patterns it's seen before. If your situation is unusual or complex, you'll likely need to escalate to a human. When an AI search result seems authoritative, remember that it's generating responses based on statistical patterns, not fact-checking against reliable sources. Perhaps most importantly, understanding AI helps you think more clearly about human intelligence. We often take for granted the remarkable things our brains do, the way we understand context, maintain consistent beliefs about the world, learn from just a few examples, and adapt our thinking to completely new situations. AI's limitations highlight just how sophisticated human cognition really is. So what is AI actually? It's software that recognizes patterns in data and uses those patterns to generate outputs that can seem remarkably human-like. It's not thinking, understanding, or conscious. It's performing incredibly sophisticated statistical analysis. It can do many things that traditionally required human intelligence, but it does them through pattern matching, not reasoning. This makes AI simultaneously powerful and limited, useful and potentially misleading. It's a tool that can augment human capabilities in remarkable ways, but it's not a replacement for human judgment, creativity, or understanding. The key to navigating our AI-enabled future isn't to fear these systems or worship them. It's to understand what they actually are so you can use them effectively and skeptically in equal measure. The next time someone tells you that AI is going to think its way to superintelligence or that it truly understands what it's saying, you'll know better. And that understanding might be the most valuable skill in an age of artificial intelligence.